Okay guys, let's go ahead and put away our pencils. Get out our red pens. Your pencil should be inside your blue box, and you're only writing with red pen now. Thank you for doing a great job with your mountain math this morning. I will check it when I get back, and I'll get all of your grades in and everything. Let's go ahead and look at number 21. Here we have 36 divided by -9. Well, this one you should be a pro at already. If you had any questions about this, then you should have turned to your integer notes and seen that when we're dividing, if the signs are different, the answer is negative. So our answer is -4. Be sure that if there's anything that you're having to write in or correct, that you're doing that in red pen and that you're putting all of my notes and all of my work along with the answer so that next week you can look at it and kind of remind yourself of what you're supposed to do. Okay, number 22, we have a point, a coordinate called W, and the coordinates are 1, 0. So the x coordinate comes first, that's 1. The y coordinate comes second, that's 0. So we just break up the point, and then we need to graph that point on the coordinate plane. So we go left and right first, so 1 to the right, since it's +1. And then we don't go up or down at all because our y-coordinate is 0. So we are on the x-axis at 1. You need to put a point there and make sure that it's labeled. It needs to be labeled point W. Number 23, we have two fractions, 7/10 and 6/12. So there's a lot of different ways that we can compare fractions. So each week I'm just going to kind of pick the easiest one for the numbers that we have. So you can refer back to all of your mountain math weeks and see, is there a skill that I learned or that I remembered when we did our mountain math last week or the week before that I can use for these fractions. So this time I looked at 7/10 and I said, I know that 7/10 can also be easily written as a decimal because it's 0.7, which also reads 7/10. So I'm changing both of these to decimals. Now 6/12, I know that that is 1/2, so I'm going to go ahead and simplify that fraction because I have memorized that 1/12 equals 0.5, or 5/10. So now that I have them both in decimal form, it's really easy to compare them. So 7/10 is more than 5/10, so I'm going to use that greater than sign. Okay, on number 24, I have 5 numbers, 12, 12, 20, 25, and 30. So the range is just the biggest number minus the smallest number. 30 minus 12 is 18, so my range is 18. The mean is where we take the average. So it's where we add up all the numbers and then divide by the number of numbers that we have. So we're going to add up all 5 numbers and we get 99. And then I'm dividing by 5 because I have a total of 5 numbers. And I got 19.8, or 19 8/10. So if these were your 5 grades in math class, then your average would be a 19.8. But I know none of us have those grades. All right, letter C is to find the median. That's the middle number. And so these numbers are already in order. If they weren't in order, I would need to put them in order, and then I just find the middle one, and that's 20. So that is our median, kind of like the median going down the middle of the road. This is the middle of our numbers. The mode is just the number that you see the most. So 12 is the number that we see the most, so it is the mode. Number 25. We have a chart that compares the number of boxes to the number of shoes in those boxes. So if I'm at the store and I see 3 boxes, I assume that there's going to be 6 shoes with those 3 boxes. So that's 2 shoes per box. And I see that that is the same relationship. 3 times 2 is 6, 5 times 2 is 10, 6 times 2 is 12. And so I can just multiply 4 times 2 and I get 8 shoes. Number 26. Number 26, gives us two rectangles, and I drew these really lousy, but those are both rectangles and they're supposed to be similar. And I see that the length of the rectangles has a relationship of times 5. So 2 times 5 is 10. And if these are similar figures, then 3 times 5 will be 15. So my missing length is 15. For number 27, all year long, I expect you to get out your integer notes, which is at the beginning of your journal. And I see that I'm adding, and my signs are different. So if I have different signs, I subtract and take the sign of the larger number, the one with the larger absolute value. So 45 minus 20 gives me 25. And my bigger number is the 45, so I'm going to keep that positive sign. So my answer is positive 25. And now that you have checked your mountain math, it's the end of the week. So normally you would be turning this in, but I'm going to ask you to hang on to it until I get back. So go ahead and just keep that in your folder. Make sure that you have labeled it at the top so that it says the week beginning on September 21st. That way we can keep track of which one goes with which week. So you'll be turning in this one and next week's mountain math when I get back. So you can go ahead and put away your red pen, get your pencil back out, and we are going to continue with the lesson. Thanks, have a great day, and I hope you have a wonderful weekend. Alrighty, so if you would go ahead and take out your Unit 2A quiz review. The reason I called it Unit 2A is because we're not quite finished with Unit 2, but we're going to go ahead and do a quiz here at this point. And so we'll spend the first half of class reviewing, and then the second half of class you will be able to take that quiz. Now, this quiz is going to be extremely close to the test you have coming up here on October 6th. So that's about a week and a couple of days away. So make sure that you're paying very close attention, that you're following along with me, and that your work looks exactly like mine. I want you to get 100 on this review today and 100 on the quiz as well. And I will let you use your notes, including this review, on today's quiz. So the better your work, the better your quiz grade. Okay, number 1 says, graph the solution for the inequality on the number line. And be careful about open and closed circles. So let's remember, let's go ahead and remind ourselves that an open circle, okay, so something that looks like this, means that the solution does not actually include that number. So that's what we use when we have either a greater than or a less than symbol. Now a closed circle, one that's filled in, does include the number that it's sitting on, which means that that is what we use when we have greater than or equal to, or when we have less than or equal to. So if you have that equal to part, then we have a closed circle. So in this case, we just have less than. Well, there's no equal to, which means that it's not going to be a closed circle. We're going to have an open circle. So we can go ahead and remind ourselves of that so we don't even have to think about it later. So now all we have to do is solve this inequality and then graph the solution. So let's start with our inequality. 3 minus 2x is less than 11. Now I know that a lot of us may really kind of prefer to see the x's, the variables, first. So this is a perfectly fine way to have it written. If you would rather rewrite it with the x's first, you can do that. Just make sure that you include whatever sign is in front of it. So the signs always have to stay with whatever's behind it. So I'm going, and this is a positive 3. Okay, so I'm going to go ahead and rewrite this, if you'd like to, as negative 2x plus 3 is less than 11. The same exact problem, this just came over here. So now the first thing I want to do is get rid of my addition. So I'm going to undo addition by subtracting 3 from what? From both sides. I know I heard somebody say that. So 3 minus 3 is 0. I can cross those out, and I have negative 2x is less than, let's see, 11 minus 3 is 8. So now I want to get rid of that negative 2. How do I undo multiplying by negative 2? Well, I'm going to divide by negative 2 on both sides. So that gives me just x. Now wait a minute. Because I'm dividing by a negative number, I have to do something extra special. So I have x, but then I have to swap my sign. So dividing by a negative number means I have to flip the sign. Instead of it being less than, I have to change it to greater than. Now you should have your integer notes close by. And we know that whenever we're dividing, if the signs are different, the answer will be negative. So this is going to be negative 4. X is greater than negative 4. So we need to graph this now. I know I'm going to have an open circle because it's not it's not greater than or equal to, it's just greater than. So I'm going to put an open circle here on negative 4. And since it's greater than, that means that it's going to be all the numbers that are bigger than or greater than negative 4. So don't just put your circle, you also have to show me which direction you're going. So this is what our solution would look like. Okay, number 2 says a triangle has angles that measure 84.2 degrees and 14.3 degrees. So we're missing an angle somewhere because we know that triangles have 3 angles. Write an equation that could be used to find x, the measure of the third angle in the triangle. So there's a couple of ways that we could do this. And whenever you're writing equations, you have to be a little bit flexible because there's lots of different correct ways to write an equation. So the answer choice that you choose may be written a slightly different way, but still mean the same thing. So we know that it has to add up to 180 degrees. Everything adds up to 180 if it's a triangle. Now I'm given 84.2 degrees, and I'm given 14.3 degrees. But we know that there has to be some extra angle in there. And we don't know what that is. So I'm just going to call it C. Actually, it says to call it X, so we're going to call it X. Okay? So if I add up these two, plus the measure of whatever that unknown angle is, then I should get 180 degrees. Now another way to write that, and this is using algebra. So if I were to subtract 84.2 from both sides, and if I were to subtract 14.3 from both sides, then I would end up with this, which would be the same thing. X equals 180 degrees minus 84.2 and minus that 14.3. So this is what I was talking about. Both of these are correct ways to write this equation. They really mean the same thing. I've just subtracted and moved things over here to get x by itself, or here I've just kind of listed things out that I'm given in the problem. So be flexible. If it's a multiple choice question, write down what you think, but then check and see which answer choice is just the same thing as yours in a different form, if you don't see exactly what you wrote. Okay, so I'm going to go on to number 3 now. It says write a word problem that matches this equation. I'm going to let you write your own word problem, but I'm going to give you my word problem to kind of help you get started. So I see that I have 7 and that it's attached to nothing. So that 7 is just off by itself. And then I have 0.5x. So this x is going to have to be like per something. So I'm going to talk about like tickets. Okay, so I'm going to say parking at a Little League baseball game costs $7. Okay, so that $7 is no matter how many people go. I'm just chalking up $7 just to park. Tickets cost 50 cents per person. Okay, so 50 cents times that however many people are going. So X is my people. I'm going to say X right there. If a group pays a total of $24, okay, so that total means everything equals $24, how many tickets or how many people attended the game? Okay, so you're welcome to write something similar to mine, but I'd like for you to kind of change up the scenario at least a little bit. So I'm going to put about 1 minute on the clock. You're welcome to use your neighbor to collaborate with, and I need you to write a word problem to match this equation. And go. Okay, so let's move on in 5, 4, 3, 2, and 1. Let's move on to number 4. Okay, Kevin read 40 pages of a new book the first day he bought it. After the first day, he read 12 pages a day. The book was 100 pages. We need to write an equation that could be used to determine how many days it took Kevin to finish the book. So, I know that the book is 100 pages. So, the book was 100 pages. So, I'm going to have equals 100 over here. Now, he read 40 pages the first day. So, it doesn't say anything about 40 pages per something or 40 pages each. It's just 40 pages, period. So I'm going to put my 40 pages right here. Now, after the first day, he read 12 pages a day, or 12 pages per day. So I'm going to add 12 pages, but I know that this is each day, so it's not just 12 pages and I'm done. It's 12 pages each day. So I'm going to say 12 times D, for D is the number of days. Now, we're not being asked to solve this problem. We could, if we wanted to solve it, we would say minus 40, because I want to get rid of whatever is not attached to D. And then I would divide both sides by 12, and I could figure out how many pages we read each day. But in this case, all we got to know is that this is 40 plus 12 pages per day equals 100 pages. Now, another way to write this, I could swap these around, and I could say 12D. So 12 pages per day plus those 40 pages on the first day gives me 100 pages. So it really doesn't matter which way I write it as long as I keep this positive sign here and this positive sign here. All All right, let's look at number 5. We're using Algebra Tiles on number 5. And we're also going to solve it just using regular algebra. So make sure that on your paper should look exactly like mine. You should have all of my work on your paper as well. And you'll be solving this 2 different ways on your review. So we have the equation 2, okay, so this is positive 2, plus 2x, here's our plus 2x, equals 6. Here's our positive 6 here. So we're going to solve this. The first thing we always want to get rid of is whatever we are adding or subtracting. So I want to get rid of this 2. I want to get rid of these whole numbers. So I'm going to say, I'm going to put in a minus 2 so that those can cancel out. Now if I'm going to put minus 2 on the left, what else do I have to have? Well, I have to have minus 2 on the right, because whatever we do to one side, what? You must do to the other. So that's what we're going to do. And then these cancel out also. So now we're left with 2x equals 4. Now I have to divide up both sides into 2 parts. So I'm going to divide this into 2 parts and divide this into 2 parts. And what I find is that this x equals 2 and this x also equals 2. So I'm going to get x equals 2 here. Now let's go ahead and solve it algebraically also. 2 plus 2x equals 6. Now we could rewrite this as 2x plus 2 equals 6. Let's go ahead and leave it this time. I want you to see that it works out either way. So whatever is not attached to the x, I'm going to get rid of. So I'm going to say, well, this is a positive 2, so I'm going to say minus 2, just like we did here, minus 2, minus 2. Now these cancel out like we saw right here. So we're left with 2x equals 4. So we have 2x equals 4. But I want to divide this side by 2 and divide this side by 2. And we get x equals 2. So look at that. We got the same answer 2 different ways. Now on your test, if you see algebra tiles, you're welcome to just solve it using regular numbers if you want to. Now on this review, since I'm doing it with you, I want you to have both ways all the way worked out, and then you use what works best for you when you're on your own. Let's look at number 6. Number 6 says solve the inequality. So I have 5x plus 0.9 is greater than or equal to 3.9. Well, the first thing I can get rid of is the addition, so I'm going to subtract. Let's get rid of that. And I'm left with 5x is greater than or equal to, let's see, I subtract, bring down my decimal, it's a 0 and a 3, so 3.0. So really, that's the same as 3. I can get rid of this if I want to. 5x is greater than or equal to 3. Now I still need to get x by itself, so I'm dividing both sides by 5. And I get x is greater than or equal to, I need to go ahead and work this out. 3.0 divided by 5, bring your decimal up to your quotient. That does not fit, but 5 goes into 30 6 times. Okay, so I'm going to put 0.6 here. Now hold up a second. Back here on number 1, I flipped my sign over. But I didn't flip my sign over here. I wonder why. Well, let's look a little closer. On number 1, we were dividing by a negative number. And whenever you divide by a negative number, we have to flip the sign if it's an inequality. Here I'm dividing by a positive number, so we don't have to do that step. Greater than or equal to stays the same. All right, number 7. Consider the inequality 3x plus 2 is greater than negative 4. And we have that all modeled out for us. 3x plus 2 is greater than 4 negatives, or negative 4. So we're going to solve this both ways. Again, I want you to have all the tools available to you in your toolbox. So I'm going to start by getting rid of these 2 positives. Well, how can I get rid of 2 positives? Well, I can put 2 negatives. But if I'm going to put 2 negatives here, I also have to put 2 negatives here. Okay, so these 2 cancel out. And those cancel out. That's a 0 pair. And then I can't cancel out anything over here because I don't have any positives to cancel out with these negatives. So those just stay the same. I've done the same thing to both sides. I could cancel over here, but I couldn't cancel over here. So we're done with that step. Now, I need to divide up what I have left. So I have 3 x's, so I need to divide this side into 3 parts. 1, 2, 3. And now I need to divide this side into 3 parts. So I've got 1 part, 2 parts, 3 parts. So this x fits with this negative 2, this x fits with this negative 2, and this x fits with this negative 2. So we know x is greater than, okay, it's not equal, we got to keep that sign, and we didn't divide by a negative, so it's greater than negative 2. Let's solve it one more way. So we have 3x plus 2 is greater than negative 4. All right, well, here we put in negative 2, so I'm going to do negative 2 or minus 2 here and here. Notice I was able to cancel out here, just like I'm able to cancel out here. So I'm doing the exact same thing in my picture that I am when I just used algebra. So we will bring this down. 3x is greater than negative 6. And now I'm going to divide this side by 3 to get x by itself, and also divide this side by 3, so that we get x is greater than negative 2. Remember your integer notes. A negative divided by a positive is a negative. So we got the same thing both ways. Again, on your quiz and on your test, you choose. Either method will get you the same answer, or do it both ways and make sure that they match. It's a great way to check yourself. Number 8. The school librarian has a budget of $840 to spend on books. She orders from a company that charges $11 per book, plus a $25 shipping fee per order. So let's stop there and look at what this is saying. It's saying that she's got $840 that the principal gave her to buy some books for the library. Each book costs $11, and no matter how many books she buys, she's going to pay a flat fee of $25 shipping. So she can buy 1 book or 2,000 books, and shipping will be $25. The librarian uses the inequality below, right here, where B represents the number of books that she's ordering, so $11 per book would be 11B. And she's going to use that inequality to determine if she has enough money to place an order for the number of books that she wants to buy. So let's see, the librarian already has a list of 50 books that she wants to order. So she's had this list going, she knows what she's definitely going to buy. She's definitely buying these 50 books. But she wanted to order, or she planned to add another 45 books to her final order. So she knows she needs 50 books. She wants to add another 45 books. So that is, let's see, 50 books and 45 books, that's 95 books. And we want to know if she will have enough money to order all 95 books, and we have to explain. So yes or no, and then why, explaining the math. Why or why not? Does she have enough money or does she not have enough money? So we actually need to solve this problem. So let's plug in what we know. Now, I already have an inequality here. And I'm going to plug in this 95 books for B. So this is the same thing that we do when we solve an equation, and then we check our answer by plugging it back in. Remember, plug it in, plug it in. We want to plug it in and see if it fits. And that's what we're going to do here. So if I have $11 times 95 books, plus that $25 I've got to pay for shipping, we want to see, is that less than or equal to $840? And the reason it's less than or equal to instead of just being equal is because I don't have to spend the whole $840. Okay, if that librarian has a little bit of money left over, that is perfectly fine. No one's going to get on to her for that. So she just needs to make sure that she's not spending more than $840. So it can be $840 or less than. Okay, so let's start by subtracting. Oh, I'm sorry. That's not what we want to do. I want to multiply. So $95 times 11. $95 times 11, or 95 books times $11. 1 times 5 is 5. 1 times 9 is 9. Put a placeholder. 1 times 5 is 5. 1 times 9 is 9. Add, and we get $1,045. Okay, there's nothing behind the decimal here, so we're just going to bring this right on over. $1,045 just for the books. That doesn't even count shipping, so we already know she's not going to have enough money. Let's go ahead and finish this out. Okay, so we have $1,045 plus $25 for shipping. Let's add that up. 5 plus 5 is 10. Carry the 1. That's 7, 0, and 1. So all together, if she orders all of those books, she's going to be paying $1,070. Well, is that less than or equal to $840? No, she is over her budget, so she cannot buy all 95 books. She probably have enough for 50, but definitely not for 95, so she's going to have to cut back. So I'm going to go ahead and put this part here. No, she does not have enough money, but I want you to explain why. Basically, you're putting what we just did into words to explain to her, like, I'm sorry, you don't have enough money, so let me explain to you why you don't have enough money and what you need to do. You're going to help her out there. So take about 30 seconds. Alrighty, so we are coming back now to our last problem. Find the value of x in the following equation. So we are just solving this equation, and then we have to bubble our answer. So we need to practice and make sure that we understand exactly what we need to do when we're bubbling. So let's solve here. 6x plus 3 9/10 is equal to negative 16 5/10. Okay, let's start by going ahead and getting rid of our addition. So we're going to subtract 3 9/10. Those cancel out, and I'm left with 6x equals, okay, so I've got the same sign. I'm going to subtract and take the sign of the bigger number. So, I'm sorry, subtract and keep the sign. Wait a minute. I'm confusing myself. Okay, yes, so I'm going to sit here and I'm going to actually add and keep the sign. That's what I meant to say. Sorry about that, guys. Y'all know what I'm talking about. Okay, so 5 plus 9 is 14. 1 plus 6 plus 3 is 10. And 1 plus 1 is 2. And of course, it's a negative. You're looking at your integer notes. And we know that this is a negative because both are negative. Okay, so now I'm going to do my last step and divide both sides by 6. Okay, so x equals, okay, I know that a negative divided by a positive is going to give me a negative answer. Let's go ahead and put that right there. And we can go ahead and do some division. So 20 4/10 divided by 6. Bring up that decimal. 6 does not go into 2, but it goes into 23 times. So let's finish up our division. 3 times 6 is 18. Subtract and get 2 and bring down a 4. 6 goes into 24 4 times. 4 times 6 is 24, and we are done. So negative 3 4/10 is my solution. So whenever you are trying to put an answer into the bubbles here, always make sure that you put either a negative or positive. So bubble in that negative. And then I can't just put 3.4 right here because that's not where the decimal point is. This is our decimal point. So I need it to be 3 and 4 right here. So bubble in your 3 and bubble in your 4. It's very important that we bubble them because that's what the machine actually reads. Now you can leave the rest of these blank. If you want to bubble in a 0, you can. Okay, the machine won't care as long as you have everything in the right place and you've bubbled in all of the digits that you need to and your sign. So at this point, we're going to go ahead and take our quiz. You have a quiz that is going to be just like this, and you see it right there in your packet with you. So you are welcome to use your notes. You are welcome to use this review. You are welcome to use your journal, anything that you have, but you must take this quiz on silence. It is by yourself. I want to see what you know from this unit so far. So best of luck to you, and I will see you soon.